Okay, so today we're looking at Chapter 6 review for the upcoming midterm exam. We've got questions 21 through 33 here. Rewrite as a single logarithm for number 21. In order to use the property that we talked about with the minus between them, with the subtraction, we have to take this 2/3 and put it up as an exponent. So this becomes log base 7 of b to the 2/3 power minus log base 7 of c. Now that we have the same log base 7 for both of these, we can combine them as a single logarithm. This becomes log base 7 of b to the 2/3 power divided by c. This would be your answer for number 21, using the properties from section 6.5. Look those up if you're not familiar. Number 22, same thing, only now we've got three different logarithms we want to combine as one. We're going to focus on the first two first. Once again, if you have a coefficient out front, it has to go up as an exponent before we can simplify down to a different logarithm. So this becomes log base 7 of b plus log base 7 of c cubed minus log base 7 of 5. At this point, when I have a plus between, I'm going to take the first two first. Plus between means I multiply, so these two become log base 7 of b times c cubed, of course, minus log base 7 of 5. And now I'm going to work this way here. With a minus between them, that means I divide, so this becomes log base 7 of bc cubed divided by 5. Again, we're not dividing by the log base 7 by 5, we're just doing that. So it's log base 7 of bc cubed all divided by 5. So that's your answer for 22. 23, to evaluate this, change of base theorem is the easiest way. This is log of 12 divided by log of 2. I misplaced my key, so I'm going to use a calculator, do it the old-fashioned way. And this results in an answer to the nearest hundredth of 3.58. Number 24, same thing here. I'm going to ignore this 5 out front first and just multiply it by the end, or multiply by it at the end. This is 5 times the log of 42 divided by the log of 7. In my calculator, I'll put my calculator under here. Log of 42 divided by log of 7. That's that. I multiply by 5, and I get 9.60. So that is my answer, 9.60. Number 23, I'll just leave the calculator up here. Number 23, I have 3 to the L equals 0.27. In order to solve for a variable in the exponent, we have to use logarithms. This becomes log base 3. Remember, the base of your exponent becomes the base of your log. Log base 3 of 0.27 equals L. And now using my calculator, I can solve log of 0.27 divided by log of 3. Gives me an answer of negative 1.19. And I'm done with that page. We're going to keep on trucking. Number 26. Once again, same problem. Basically, same problem. Turn it into a logarithm. Log base 11 of 0.77 equals p. And now on the calculator, that is log of 0.77 divided by log of 11. Gives me an answer for p of negative 1. I'm sorry, that's not right. Look at that. Negative 0.11. Scribble out. Negative 0.11. That's our answer there. It's the nearest hundredth. Next one. In order to get this an exponential, the form to do a logarithm, we have to get rid of that 5. So we divide each side by 5, and we're left with 2 to the x equals 3/5. And now we're ready. Log base 2 of 3/5 equals x. Just that reverse circle method. So on my calculator, it's log of 3/5 divided by log of 2. We get that, negative 7.4. Negative 0.74. Can't talk today. Number 28. First thing we have to do is get rid of this 22. So we're going to add 22 to both sides. And we get 3 to the 2x minus 1 equals 37. At that point, we're ready to turn it into a logarithm. So this would be log base 3 of 37 equals 2x minus 1. Log base 3 of 37 again, it's going to be log of 37 divided by log of 3. We get this answer right here. So 3.29 equals 2x minus 1. And of course we're going to add 1 and divide by 2. So plus 1 divided by 2. And we get an answer, x equals about 2.14. Okay? Shift gears here. Now you really have to know your properties here of changing bases from a single base or single logarithm to many of them. Okay, so you have to basically at number 29 look at, hey, how can I turn 7 times 2 or 7 times what to get 28? And you figure out that 7 times 2 times 2 equals 28. Okay, so another way of writing log base b of 28 is saying, well, this is log base b of 7 times 2 times 2. And if we want to expand that, if we're multiplying them in a single logarithm to write them as their own individual logs, we add them. So this is log base b of 7 plus log base b of 2 plus log base b of 2. That's what this equals. And now we know these values. Log base b of 7 is given as 1.7712, and both of these are 0.6309s. So using the calculator, we add these three up, and we get an answer of 3.033. The next two, number 30 and 31, use basically the same idea. It's just a little bit tougher. You have to recognize that 1/3 is the same as 4 divided by 12. So I'm going to look at this question as 4 times, I bring the exponent out front, 4 times log base b of 4 over 12. Okay? And now I want to rewrite this as 2 separate logarithms, so this becomes 4 times log base b of 4 minus log base b of 12. I'm going to run those first before multiplying by 4. I know what these are again. Log base b of 4 is given, log base b of 12 is given. So I'm going to do 0.7124 minus 1.277. And for this log base b of 4 minus log base b of 12, I get negative 0.5646. So my answer is 4 times negative 0.5646, which gives us an answer of negative 2.26, we can call it. That's your answer for number 30. For 31, a little bit tougher yet. You have to recognize we can only work with 5s and 2s. 1 over 25 is the same thing as 2 over 50. And 2 over 50 in terms of 2s and 5s is 2 over 2 times 5 times 5, because 2 times 5 times 5 equals 50. We basically are just trying to break 50 down into multiples of 5 and 2. From this point right here, we're going to say that instead of log base b of 1 over 25, we've got log base b of 2 over 2 times 5 times 5. And now we're going to separate that into separate logarithms. So I'm going to come around here and say this is log base b of 2 minus, because I'm going to subtract, because I'm dividing all of these, so I parentheses, log base b of 2 plus log base b of 5 plus log base b of 5. And the reason that I added these is because they're being multiplied in the bottom. The reason I put this in parentheses is that this 2 is dividing everything by it. So this is what we need to do. Now I know what each of these equals, so I'm just going to basically take that expression and plug it into my calculator. Log base b of 2 is 0.1231 minus, and then in parentheses, got another log base b of 2, so 0.1231, plus 2 of the log base b of 5s, which is 0.893 plus, I messed up. Let me back up. 0.2, there's the first one, minus the log base b of 2, 0.1231, plus log base b of 5, which is 0.893, plus another one, which is 0.893. Plug it in, and we get this answer, which is correct. Negative 1.786 is what you get for number 31. Okay, 2 left. And 32 is a doozy. First thing you have to do is find the rate. A machine is used in industry, depreciates continuously, so that after 3 years it's worth half of its original value. Since it's continuous, we've got to use the PERT formula. Okay, and I say, hey, it starts out worth 1. It's worth half of its original value, so A is 0.5 after 3 years. So we've got E, we want to solve for R, and we know T is 3 years. Okay, so divide by 1, that's gone. Right now I've got 0.5 equals E to the 3R. To get rid of an E, you take the natural log of both sides. Okay, so this becomes natural log of 0.5, and then the natural log of E, just basically natural log both sides. Natural log of 0.5, natural log cancels out E, leaves you with just 3R. So in my calculator now, I've got the natural log of 0.5, and then I have to divide by 3 to get R all alone, and we get that. So our rate, once we divide by 3, the rate is negative 0.231. And now that's what we're going to use to answer the problem. It says, after how many years to the nearest month would the machine be worth 75% of its original value? Well, it's time for PERT again. Okay, so we want to know, hey, it was worth 1. Now it's worth 0.75. We still have E. We know the rate now is negative 0.231, and we want to know what's T. Okay, again, 1 disappears. And just like before, to get rid of an E, get everything to drop down, we take the natural log. So we have natural log of 0.75 equals negative 0.231 T. Natural log of 0.75, we're going to divide that by negative 0.231, the rate we had found in the first part. And we get T equals 1.25 years. It did ask for how many months, so you would say 1 year and 3 months, or 15 months. Finally, number 33, this one's pretty easy. It's compounded quarterly, okay? So if you're compounded quarterly, you're not using PERT, you're using the other interest formula that we did, which is A equals P times 1 plus R over N to the NT. You just have to remember what all that stuff stands for. $500 is invested, that's your principal, that's what you're starting with. 1 plus, the rate is 10%, so we're going to write that as 0.1 or 0.10. N is the number of times you compound per year. If it's compounding quarterly, that means 4 times per year. And then N again up here, so that's 4. How much money, what is the balance at the end of 5 years? So T is 5. So basically we can enter this all in the calculator all at once. We've got 500 times 1 plus, now this 0.1 over 4 I'm going to put in its own parentheses. Close those parentheses. Now I'm going to close the parentheses around the 1, and now I want to put this to the 4 times 5 power, which is 20, 20th power. So you find that, hey, after 5 years, you've got yourself $819.31. It's the end of the Chapter 6 review.